today's our second to last lesson in Module 3. It only goes up to 3.16, so today's the second to last. And then this Friday, you'll have your Module 3 test. Looking ahead to that, we'll talk about that as it gets closer. But for today, we're doing Module 3, Lesson 15. And your learning goal is to be able to solve multi-step word problems, meaning you have to do more than one thing to solve the word problem. And then use what you know about the size of fractions to decide if your answer is reasonable or not. Okay? So our problem of the day says, in a race, the second place finisher crossed the finish line 1 1/3 minutes after the winner. So if the winner took 1 minute, how many minutes did the second place finisher take? If he took 1 minute and 1/3 minutes more than the winner. If the winner finished the race in 1 minute, how much did the second place person take? How much time? Talk to your table group. If we know that the second place winner crossed the finish line 1 1/3 minutes after the winner, however long the winner took, how do we find the second place winner's time? We have to add what? 1 1/3 minutes. Very good. Then the third place finisher was 1 3/4 minutes behind the second place finisher. Okay, so the first, do we know how long it took the winner to run it? Not yet, but we know that the second place took 1 1/3 minute longer, and then the third place finisher took 1 3/4 minutes longer than the second place. Okay, the third place finisher we know took 34 2/3 minutes. So the question's asking us, how long did the winner take? Okay, so we know that the third place finisher took how long? 34 2/3. About how much faster was the second place? 1 3/4 is pretty close to what number? 2. So about how long did the second place person take? What's 34? 34 2/3 is pretty close to what number? 35. And the second place was about 2 minutes faster. So about how long did the second place take? About 33 minutes. What about 1 1/3? That's pretty close to what number? So if the second place probably took about 33 minutes, about how fast did the winner go? About 32 minutes. So our answer should be around 32 minutes. Okay? But let's actually solve it. Here's what I mean when I say drawing a tape diagram will really help you. Let's say that this is the winner. The amount of time that the winner took. And that's what we're trying to find out, right? Now, if I wanted to draw a bar that shows the second place, how much longer would the second place be? The second place person took some extra time, didn't they? How much longer did second place take compared to the winner? Everyone? 1 1/3. Okay. What about, hold on. We know that the second place winner always takes longer than the first place. That's what makes them second place, yeah? If it's faster, they would be the winner, yeah? So if this amount, do you guys see how this is right where the winner left off, right? This extra time is what made him second place, yeah? How much longer did the second place winner take compared to the winner? 1 1/3 minutes. Okay. What about third place? Does third place take longer than the winner? Does it take longer than second place? Okay, so let's say this is third place. It should be the longest one. This is where the first place cut off, and this is where the second place cut off. Do you see that? Yeah? Okay, so this is third place. How much longer is third place compared to second place? 1 3/4 minutes. Now the problem tells me that the third place finisher, the entire thing for the third place, this entire bar, is how long? 34 2/3 minutes. So all of this is 34 2/3 minutes. I'm going to write it differently. Okay, so given that information, now that we've drawn the tape diagram, how could we solve if we know this whole thing is 34 2/3 minutes? How could we figure out how long the winner took? Well, do you guys agree that this part right here is the winner's part? Yeah? Is it the winner's time? Is this how long the second place? Do you see how this is the same part as this? So how long is this black area right here? 1 1/3, yeah? What about this last area over here? How long is this last area? 1 3/4. So if I know that this section right here is 1 1/3 and this section is 1 3/4, I don't know this section, that's what I'm trying to figure out, but I know the whole thing is 34 2/3, how can I figure out how long the winner took? Okay, if we know that the entire time is 34 2/3 minutes, 34 2/3 minutes, what do we have to take away? We have to take away this time. How much is that time? 1 3/4. And then we have to take away this time, which is what? 1 1/3. Will we be then left with the amount of time that the winner took? Yeah. Very good. We can't really subtract yet because we don't have common denominators. What should our least common denominator be? 12. Okay. So let's rewrite those fractions. 34 2/3 is the same as 24 and how many twelfths? 34 and how many twelfths? 8 twelfths. Okay. 1 3/4 is the same as 1 and how many twelfths? 9 twelfths. 1 1/3 is the same as 1 and how many twelfths?
4.
Underline it. Well, we can see here the question's asking, how much salt does John have left? That's what we're trying to figure out. Yeah? Okay, let's now read it again and circle the important information. Well, we know he used up already 1 3/4 kilograms. That seems important. He then used another 3 4/5 kilograms. That also seems important. Finally, we know that in the beginning, he started with 10 kilograms of salt. So if we circle the important information and underline what the question's asking, that shows that we've done the first step. We've read the problem. The second step is what? D, which stands for? Draw. Okay, let's draw a tape diagram. All together, how much salt did John start out with?
10.
Okay, so let's draw a big piece of tape and show that he started with 10 kilograms of salt. Then he used up some of it to melt the ice on the sidewalk. How much did he use at first? 1 3/4 kilograms. Then he used some more. He used another 3 4/5 kilograms. Whatever he has left is the amount he has left. Looking at this piece of tape, it becomes clear that what we need to do is we need to take the total amount and subtract the amounts that he's used. So you have two ways to do it. You could do 10 minus 1 3/4 and then minus 3 4/5, yeah?
Yeah.
Or I could add up the amount that he's already used. How could I find how much he's used total? Well, I could add 1 3/4 plus 3 4/5. Then subtract that total from 10 kilograms. Before you get started, let me ask you a question. About how big do you think the answer should be? Well, 1 3/4 is pretty close to what? 2. 3 4/5 is pretty close to what?
4.
So this is pretty close to 2, and this is pretty close to 4. How much has he used up?
6.
Yeah. Did he use more or less than 6? Because both of these we rounded up. So about how much do you think he'll have left? Around 4, right? So we want something around 4, maybe a little bigger than 4. So if you end up with an answer a little bigger than 4, you know you're probably right. In this problem, once we see that he's trained so hard that he's improved by 1 19/20 of a minute, we have to compare that to his original goal, which was 2.5 minutes. The question is asking how much more time he needs to improve by. So we have to draw another tape diagram. Here's how much he's improved by, 1 19/20. But his goal was how much? 2.5 minutes. Did he reach his goal yet? No. This part over here is how much he still needs to shave off in order to improve his goal. So how can I figure out how much more he needs to do? I have to do 2.5 minus 1 19/20. Go ahead and do that. 2.5 minus 1 19/20. Well, I can rewrite 2.5 as 2 10/20. Do you agree? Minus 1 19/20. And then I have to regroup. That's the same as 1 30/20 minus 1 19/20. So my 1's go away. If I have 30/20 and I take away 19/20, what do I end up with? 11/20 of a minute is how much more he still needs to improve by.